Okay, so this video is for assignment PC 6.2. It is the exact trig values of special angles. So let's open it up. And here we go. Okay, so find the exact value of each trigonometric function. So this is basically an exercise for the unit circle, which has been built for you in a previous video. I also built one in, there's a review video in for the end of chapter 6 that the first part of that is building that unit circle again, but you can always just go Google unit circle and you will have all the unit circles you've ever wanted. Math is fun, unit circle, look at that. You know that. Okay, so let's just get one. There's one. We'll use that one, and maybe we'll open that up in a new tab. Oh, that's too small. It's 300 by 300. How about that one? How big is that one? 500 by 492. Hopefully that'll be big enough. Open image in new tab. There we go. Okay, well, that's big enough to read. It's not that sharp. It's kind of annoying to me, but that's all right. We'll do it. All right, so back to there it is. Okay, so what we're looking for is the tangent of 60 degrees. So the first thing we want to remember is the definition of tangent. And the way to do that is to start by writing SOHCAHTOA, which you can never write too often. SOHCAHTOA, right? So that means the sine of something, of an angle, equals the opposite over the hypotenuse, right? And the cosine of something equals the adjacent over the hypotenuse. And the tangent of something equals the opposite over the adjacent, right? So that's the definitions that we're looking at. So we're looking for the opposite over the adjacent on 60 degrees. I'm going to write 60 degrees right here. We're going to erase this whole thing in a moment. But we're going to write 60 degrees right there so I can remember what we're looking for. Because now we're going to pop over to the unit circle. Boop. Oh, those disappear. Okay, so I'm going to write 60 degrees right there because that's what we're looking for, right? Okay, so here is 60 degrees on the unit circle. Okay, so that's 60 degrees in degrees. It's pi over 3, or 1/3 pi, radians. And then we have the x and the y coordinates there. You can see the point on the unit circle is 1/2 comma square root of 3 over 2. And so just by way of review, let's just do this. So we're thinking about this line on the unit circle, and we're thinking about it in terms of a right triangle like this, right? And so the x value, the distance in the x direction is going to be 1/2, right? And the distance in the y direction is going to be square root of 3 over 2, right? Okay, so just by way of review, if you're on the unit circle, the x component is the cosine of the angle, and the y component of that point is the sine of the angle. And the reason that is, let's just do cosine. Cosine, SOHCAHTOA, so cosine equals the adjacent over the hypotenuse, right? So the adjacent means it's the leg that is touching the angle, and this is the angle we're thinking about. So that makes this one the x coordinate, the adjacent, right? And what's the hypotenuse? It's the unit circle, and when you see the word unit, you should be thinking 1. So it's the unit circle. So the cosine of 60 degrees is the adjacent leg on the unit circle, which is 1/2, over the hypotenuse, which is 1, and anything over 1 is just what it is, right? So the cosine of 60 degrees is 1/2. Now, that was not asking me for the cosine. That was asking me for the tangent, right? So what's the tangent? The tangent is going to be the opposite over the adjacent, right? Which means it's going to be the y over the x, which means it's going to be a little funky. It's going to be square root of 3 over 2 over 1/2. That's the opposite over the adjacent. So let's go back over here, and now we'll get a dark color and we'll write it. Okay, so the tangent equals the opposite over the adjacent, right? And we looked on the unit circle and we saw the tangent of 60 degrees equals what's the opposite angle? The y coordinate on the unit circle of 60 degrees was square root of 3 over 2, right? Is that right? Let's check it. Wrong one. Let's check it. Yep, the y coordinate is square root of 3 over 2, and the x coordinate's 1/2, right? So the square root of 3 over 2 on top, and then 1/2 on the bottom. Now what we got going on here makes it pretty easy, because if you have the same denominator, if you have a fraction on the top and a fraction on the bottom, what you have to do is get the same denominator on each fraction. If you have two fractions, like a fraction plus a fraction, first thing you have to do is figure out how to combine those into one fraction, and then you have to manipulate it again to get the same denominator in both of these fractions that are on the main fraction. Because once you have over 2, or whatever, as long as you have a common denominator, those denominators disappear, and you're going to be left with square root of 3 over 1, which of course is just square root of 3. So the answer to the first problem, the tangent of 60 degrees equals the square root of 3. Okay, so that's not too bad, right? That's not too bad, too bad. What's the sine of 90 degrees? Remember that on the unit circle, I'm just going to draw here, pretending it's the unit circle. The x, that's the cosine, right? And the y, that's the sine. So what's the y component? The sine of y is going to be the y component of this point on the unit circle. And we know that point, 90 degrees on the unit circle, is going to be 0, because the x, you don't go either direction at all, right? Because you're just going straight up. And then it's going to be 1, because it's the unit circle, right? So the sine of 90 degrees is 1. And now you won't forget it, maybe. Maybe forever and ever and ever, you will know what the sine of 90 degrees is. That's cool, huh? Okay. So let's do a couple more, and then we'll send it going. Oh, look at that. I'm so happy when things work. All right. Well, let's do the sine of 225. So that's what we're going to remember, 225. And all we have to do, this is super simple, the sine of 225. So we're going to go over here. I'm going to erase all this garbage too. Wonderful stuff. There we go. So what's the sine of 225? Well, there's 225. There's the coordinates of the point on the unit circle where a line with the angle of 225 from the 0-degree x-axis would cross the unit circle. And so the coordinates of that point are -2 over 2 and -2 over 2. And every point on the unit circle is cosine comma sine for that angle. So the sine of that is negative square root of 2 over 2. And that's the answer to that one. Negative square root of 2 over 2. Now this, by the way, could also be, depending on what form you're using or who's setting the requirements, this could also be 1 over square root of 2. Those are equivalent. And how are they equivalent? Let me just show you real quick before I run out of time, which I have 2 minutes. So some systems say you can't leave the radical in the denominator of a fraction. So what you do when you have a radical in the denominator of a fraction, is you multiply by a fraction made up of that number, what the denominator is there in the numerator and the denominator of the thing you're multiplying by. So I'm going to multiply this by square root of 2 over 2. That is legal because why? That just equals 1, right? And you can multiply by 1 as often as you like because anything multiplied by 1 equals itself. So I multiply by 1, square root of 2 times square root of 2 equals what? 2. 1 times the square root of 2 equals square root of 2. And that's how those things go together. So let me just scroll down here real quick, see if there's anything else. No. So the only other thing, just super quick, here we have the cotangent. And remember, you got sine. You just have to look this up. Sine is the opposite over the hypotenuse, right? And the cosecant is the inverse of that. It's the hypotenuse over the opposite. And you got the cosine, which is the adjacent over the hypotenuse. And the secant is the hypotenuse over the adjacent. And then you got tangent is the opposite over the adjacent. These are all just from SOHCAHTOA. And so the cotangent is the inverse of that, and that's going to be the adjacent over the opposite. And so this is asking for the cotangent of 7 pi over 4, and on this sheet, pretty much all the angles are going to be in the unit circle. So you can go over here and cotangent of, what did it say? It was 7 pi over 4. So we're looking for 7 pi over 4. We'll find it. It's right there. So the tangent of that is going to be the opposite. It's going to be the y over the x, because remember, that's the y and that's the x. So that's going to be the opposite, and that's going to be the adjacent. So the tangent is going to be the opposite over the adjacent. Cotangent is going to be the adjacent over the opposite. So it's going to be adjacent, the x component, that's going to be square root of 2 over 2 over negative square root of 2 over 2. So those 2's cancel out, and you're going to get square root of 2 over 2 over negative square root of 2 over 2. And those are going to cancel out, and all you're going to get is negative 1, right? So that's that. Let me, the bell rang, so I just got to look for anything else that might be unusual. When you see the negative, you just have to go the other direction. So that's going to be, if that's 0 and that is negative, you're going to go 13 pi over 6 in this direction instead of the other direction. And hopefully that'll be enough for you to go on for something that's giant. You got to go around the one trip around the circle. One trip around the circle is 360 degrees, right? Another trip around the circle is 720. So you're not going to quite go 720. You got to figure out where 630 is. Same thing with the pies. Just look on there, and you're counting sixths on the way around, right? Or you're going to be counting thirds on the way around, or fourths on the way around, that kind of thing. So I got to go, and hopefully that is super helpful. And